Hey everybody, John Grimsmo here. Let's talk about Rasks. We started making these in 2015. Eric and I actually had this idea back then. We were making Norsemans for about 4 years before that, and we're like, let's make a knife that's going to be easier to make. So we simplified it a little bit. We're like, yeah, we're going to bust out a whole lot of these and let's increase production. And in the end, it was not easier. It was actually a lot harder to make than the Norseman due to some of the design choices we made. But we were committed, so we just stuck to it. We kept in it. So in this video, I'm going to compare old Rasks 2015 to 2017, and then we stopped making them in 2017 and didn't pick them up again until basically 2021 is when we started selling the first one. So there was that 4-year gap of learning and progress and gaining knowledge on manufacturing and machining and things like that to bringing you the new Rask 2021 versions. I'm pretty happy with them. They turned out pretty nice. So yeah, I want to talk about some of the differences between the two. So when we started, I designed the Norseman in 2011, and then I put it into production, and then Eric came on shortly afterwards, 6-8 months afterwards, and kind of joined me, and we've been doing this ever since 2012 together. So 2015 rolls around. I clearly remember we were in Florida at a small wedding, and him and I were talking about it, and we're like, this was like February 2015, I remember this. And he's like, let's draw out a knife. Let's make something different, something smoother, something smaller, a little bit cleaner than the Norseman. Because the Norseman, I mean, we all know what the Norseman looks like, but it's got some angles, it's got some shape, some body to it. Not everybody likes that. It's not everybody's cup of tea. So we wanted to make something that was a little slimmer and smoother. So Eric, sat down with a pencil and paper and just kind of sketched out this design right here. And that is what led to the Rask. Once I started putting that into the CAD software, then you play with the angles and you make it look and feel right. So we did. And then that led to a whole string of moving out of the garage and finding a big shop and buying our DMG Mori. And we actually bought the machine and then we found a shop. Didn't have a place to put the machine yet. And cascade of events, and now here we are 5-6 years later. I'm in my studio now with 2 guys behind the cameras, filming all kinds of cool stuff. And the Rask is back. So this right here is the very first Rask. There's not even a number on it. It just says prototype. I think there should be a date on it. Yeah, April 2015. So we got that big shop, the first shop, June. Two months after making this. So this was made in my garage on our Tormac CNC mill. You can see I 3D machined the blade bevel here. Get a little close up of that. It's not pretty. It's very chunky and chattery, but it is what it is. And we wanted a smooth bevel. Like the Norseman has milling lines on purpose. We like it, it's cool, but we wanted a smooth bevel on the Rask. So I remember going through so many different options. Do I 3D mill it like this? I remember I designed some soft jaws for a vise that would hold the blade sandwiched like this. And I had Alfred Lyon in California from AB Tools design me a 4-degree taper end mill. And he made some for me so that I could mount the blade like this and then machine both sides. And me thinking of theory was like, yeah, that'll work fine. It'll work. It's not going to chatter. Holy cow, it chattered like crazy. This needs support and rigidity, and otherwise it's just a big tuning fork, hardened steel that gets super duper thin. So that method didn't really work. That was several $100s in test end mills. But that's the learning process. So then I'm like, do we mill it? Do we grind it? Do we do all kinds of stuff? So eventually we settled on grinding. Yeah, so fundamentally, I mean, this is the Rask. The shape is almost identical to what it is now, but this is the first one and the only one made on the Tormac. I carried this. I used it all the time. Even the pivot is a little bit different than on the Norseman. The Norseman has this ovalized pivot. I wanted it round on the Rask to make it smooth and flush. And there's a feature on the back of the round that prevents it from rotating because rotating pivots are dumb. It's got a lot of the same concepts. They're both frame lock, lock bar knives with a carbonized edge. They both have over travel stops, the lock bar insert, or lock bar stabilizer. And same screws. We wanted to keep some things the same. Like there's no thumb stud on the Rask, there is on the Norseman. They both have the same screws. They have similar clips, but they are different. On the Rask, I put the lock bar cutout on the inside, not on the outside, to add to that kind of smooth, transition. Whereas the Norseman, you really see it on the outside. And also the Rask is a 3D machined with a slight curvature to the top of it. And that way every pattern basically has to be 3D machined. You have to add this machining pattern to the top to be able to create that curvature. So we had a couple different patterns. This is the angled pattern. We also had crosshatch and then starburst. And I think those were the three main patterns that we sold on the Rasks back then. But yeah, it's really cool to have this first one, the OG, and see. I haven't looked closely at it in quite a long time. It's still very similar. I've stuck to the design quite nicely. So on the original prototype, you can see this little hole right there. Right there. So that's our LBS screw, our lock bar stabilizer. And what that does is when you crank over the lock bar, because it's spring-loaded titanium, it moves this way, it gets in the way of the blade, prevents the blade from closing on you. That's what keeps the knife locked. But a lot of knives benefit from having an over travel stop so that heavy-handed individuals don't bend the titanium more than they're supposed to, which works really well. We use it on all of our knives. This one, we milled the hole a little bit too far from the inside outward, so you see that little pop there. And then on the production ones, we got the depth just right so that it didn't happen. And then on the new Rask, we're actually using a lock bar insert, which I'll show you in detail later, but you look how clean that looks. And you can see the over travel section of it, that little hook right there on the inside of the lock bar slot. And also, if you do a little side by side here, so you got prototype, you got production, 2015, 2017 production, and then new one. I went thinner on the lock bar slot, which requires more tools and smaller tools and more delicate. Tools don't last as long. But it looks clean, having that thin lock cut. Love it. So it's just like improvements, looking better and cleaner and tighter, and all the lines flow. Another little feature. Back here at the back of the clip, it's kind of hard to get just the right angles. But on the back of the clip, because there's a lot of like 3D surfaces kind of going together, I put 2 series of chamfers, like a 45-degree chamfer and then a 60-degree chamfer across that. And it worked okay, but Eric, being the guy finishing all these knives, ended up not liking it in the end. So shortly afterwards, we transitioned to this radius. It's a full radius that goes across here. And it looks much better. It cleans up much nicer. It tumbles better. And it's neat designing a knife. This knife has purposeful chamfers going around the outside, a 45-degree, but there's some round corners as well. So you get to mix and match a blend of, harsh 45s and round kind of corner rounds. Whereas the Norseman is pretty much all corner rounded on purpose, but it's cool to mix and match. Let's talk about blade grinding right now. This is something that was like theory that I've wanted to do for the entire Rask process ever since I made this one with the chunky end mill finish, also on one of the cheaper machines you can buy, my Tormac. I wanted something better. I wanted it to be perfect, and we're always striving for perfection. That's what we do here. And I'm fine taking years to do that. And we're getting there. We're pretty darn close. So I did that with an end mill. And then for the production Rasks back in the day, we made about 326, I think it was. Couple different styles through the ages. So this one here was ground with a grinding wheel, but you can see how it burned. All these dark sections right there, up there, and it doesn't always just burn on the thin sections. This burned on every pass, and that's no good. There's a point where it actually alters the the chemistry, the heat treat of the steel, and just becomes no good. This one we accidentally, or maybe we purposely tried to machine this one soft, and you can see just it burns so hard right there. So it's kind of neat that I still have these parts. And then what's up with this one? Yeah, this one burned just a little bit in the corner there. And when you're just going too fast, not enough coolant, wrong settings, wrong dress on the wheel, like grinding is a whole different ball game. Now the way that I did these is basically by using this custom-made grinding wheel. This is one that I crashed, and we'll talk about that in a minute. But these I had custom made by a company out in California. They were a few $100s, but they took 6-week lead time to get made. A lot of back and forth on the phone call with their reps and their technicians and engineers and geniuses for me try to understand how grinding works, how the particles in this material abrade the material and make the cut and make the nicest finish. So the theory was we would mount the blade. This was cut on our Mori, which is a 3-axis mill, which means it only goes up and down, front to back, and left to right. So if you want a 4-degree taper here, what we did is we machined the side of the fixture to tilt the blade to a 4-degree tilt, and then it could sit flat on a vertical, on a 4-degree surface. That way, one bevel is vertical. It's like straight up and down. Because I wanted to use a grinding wheel like this, and I wanted to get in there, and I wanted to go zip, 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 whatever it takes for as many passes or vertical, up and down, whatever, to make a nice finish. Because I thought this surface would leave a perfect finish. And it kind of did, and it kind of didn't. Turns out when you have a grinding wheel and you dress it against a grinding stick or tungsten rod or whatever, many different ways to do it, there's always tiny little imperfections in there and little grit that comes around. Like you can see the streaks on this one from poor grinding, from loading up, whatever. This leaves a bad finish on the blade. So imagine if there was one little chip right there and it goes across and it creates a pass or a bunch of passes, it's going to transfer that ding in the, around the wheel into the blade so that you'll be left with a stripe and a streak. And it was then Eric's job to polish those out. And it was not fun for him. He didn't like that. That was actually, the blade bevels was one of the big reasons why we canned this knife back in 2017, because we're just like, okay, we're done. We'll get back to it eventually. 4 years later, we did. So yeah, I can feel as I'm playing with this one, the hub is loose because I crashed this one. And then I've got another example here. This one's brand new. Never used this one. This 500 grit. So this is a 500 grit CBN resin bond wheel, 100C with aluminum core. Some of the other ones were 800 CBM resin bond. I also tried diamond, which might be this one, and it did not work. Yeah, so from my research, CBN seems to be the right choice for grinding hardened stainless steel. And then I think it was this one here that also crashed, and the whole thing just kind of fell apart. Oh, look at that. Look, this thing is so loaded up. I remember this crash. This was not a good day. I think when this kind of crash happens, I think I just turned off the machine and left and just went home for the day. What happened was, I remember Barry had just started, sometime within the past few months. Me and Eric, so it was just the three of us, and money's tight. We got Rasks due. People are waiting on Rasks, and we're waiting on this wheel, custom made, to come in the mail. It finally comes in. I throw it on the machine. I got one of my offsets wrong or something, so that it went far too much to the side. So it goes in. I'm watching it. I'm going slow. And the grinding wheel just smashes into the part. It actually moved the vices on the table quite a little bit over and destroyed the wheel, and big puff of smoke from the abrasive just kind of destroying itself into the air. And now we had no more wheel because I only bought one because we were very, very tight at the time. And then we had to wait weeks and weeks and weeks to get another one. Not fun. But even still, I was never fully happy with the finish of this wheel due to the kind of chipping and the theory that I can't just make a swipe across. I tried to go up and down, do another swipe up, another swipe down. It still never left like the Grimsmo finish, the perfect, like, this is awesome finish. So it worked, but it didn't work. And then on the Rask, on the Kern, this is how we're doing it now. This little guy is a die-cut thin wheel. It works great. They sell this mandrel. I can take it apart on the end. It's just got a simple little construction. This wheel is a 325/400, kind of in that range, grit, which I think we're doing the 220. No, sorry. This wheel is very chunky. I don't use this grit. These are now Kern. So we are present day working on the Kern. We have our lapping machine. The blades are beautifully shiny. So the blade gets milled, heat treated, lapped here, and this goes into the Kern, and this comes out. This finish, get the best view of that you can. This finish is phenomenal. And the way that I do that is I use the die-cut thin wheel at a 20/40 micron with a ROS 2, whatever that means. It's the concentration or whatever of the diamond particles. CBN wheel, and 20 micron, 40 micron. And what we do is we first, the Kern being a 5-axis machine, I can tilt that 4-degree tilt. I don't need to do it in the fixture. So I tilt the machine, 4 degrees this way. An end mill, kind of this size, comes in, does all the clearing, removes all the material, leaves a few thousandths of an inch left. Probe comes in, verifies, make sure we're like right on where we're supposed to be. Grinding wheel comes in, does roughing passes. Now, because this wheel is thin, it can only hit so much of the blade at once. So we have to go step down, across, step down, across, step down, across. So I do a roughing pass with kind of almost the full depth of the wheel. Cross, 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 cross. Probe comes in, measures the surface, offsets the diameter of the wheel from where it thinks it is to where it actually is. And then it does a finish pass. And every finish pass comes in and moves down. I think I'm doing 0.02 of an inch. There's like 500 passes down, 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 down. So it goes swipe, down, swipe, down, swipe, down, swipe, 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 500 times. But it's worth it because this finish is nuts. This is the kind of finish that I'm like really, really happy with. And I want in everything. So I'm happy with that. Except when I'm not, like on this side. Because this side had a little bit of a problem. This is a mismatch between the end mill roughing and the grinding finishing. So either the probe got a little ahead of itself and offset something the wrong way, or the end mill diameter was weird, or something. But I've had this happen every now and then, and I'm still battling it a little bit. Probably 9 out of 10 blades are great, but every now and then we get one of these weird ones. So I'm still trying to fine tune that, but when it's great, it's phenomenally amazing. One thing we added for these current day Rasks that people have been asking for, and it's a great idea, is a sharpening choil. And what that is when you have the edge like this and it goes across and you want to sharpen it and you want to, lead out into this where the blade gets thicker in the back. It's nice to have a little bump in there so that we can sharpen nicely. This one, as you can see, turned out really nice. So I played with a bunch of different angles and shapes and designs for the sharpening choil. This is what I've settled on. I really, really like it, where the edge kind of hangs down a little bit and then it transitions out super duper nicely. We tried with just a little bump and it looks okay, but it looks kind of out of place. It looks like an afterthought. So I trying to like blend everything and make it look super nice. And I'm pretty happy with this. So it's visually aesthetic, but also I'm trying to make Eric's life easy when he sharpens the knives, because his sanding belts that he's using, if they get too close to the plunge here, they will dig in and like create a scratch on the plunge. So you can see on this one, how close can you get there, Ryan? This particular one here bumps up the edge, the sharpened edge, bumps up just a little bit back there, which is not, you know, 1,000,000% perfect, but this is still the hand-done operation. And Eric is definitely playing with that to try to get it perfect every time. But that also helps end users and customers sharpen their knives and kind of lead out, so that they're not taking their sharpening stones or whatever they're using into the plunge and creating gouges and stuff like that. This right here is the pivot of a Rask. As I said before, it's different than the Norseman pivot because it's fully round on the top, but on the back side, it is it's got a shape to it. Now on the first Rasks, production ones, they were round and they had just a line, just like one, you know, sideways cut, so that it would clock like a D shape, basically, you know, where it's like this and then flat on top. And it worked okay, but I found it kind of finicky, and the flat of the D was very small, and the pivot had to like be just perfect in there. And I noticed that customers were able to put the knives together and not realize that the pivot was a little bit crooked. So you put the knife together, it feels weird because it's not fully seated. So for new Rasks, I changed that D shape to more like a baseball diamond, where it's like this on top and then it's down and then a little flat on the bottom. So I'm calling it the baseball diamond shape. This I've found, it's like a triangle. I found that it's much easier to get kind of every time. There's no way it's either right or it's wrong. If it's crooked or upside down, you feel that the pivot is not seated fully. It needs to go down lower. So it's pretty easy to align and put it in, and everybody seems really happy with it. So I like the baseball diamond. One thing I check whenever I check off on the knives and I sign my little card here is I just push my thumb over the pivot on both sides, and I feel if it's flush or if it's up a little bit or if it's down a little bit, because all the tolerances combine here. You know, the thickness of the blade, the thickness of the handles, the bearing cutouts on the handles, the pocket depth on the top of the handle, the pivot head thickness, the locating feature thickness, the screw head thickness, all of this kind of stacks and stacks and stacks and stacks, so that either it's perfect or it's not. And you know, we constantly try to make sure that everything is as perfect as we can. This one feels amazing. It's super duper flush. And we also stonewash the pivots now. In the past, we've done just a turn finish, or we've done Eric would hand sand them on a piece of sandpaper, or spin them in the drill against a piece of sandpaper and then a buffing wheel. And now we are putting them on a titanium fixture that we made, putting them in the tumbler for a couple hours, and they look amazing. On the prototype, it just says prototype, which I think is pretty cool. On the first production batch, we put the engraving and the serial number. That's the other thing. Every one of our knives and pens and products, and probably for now and forever, is serialized from number 1 up until current production. In the beginning, this was kind of a cool thing to see, like, how many can we make? And ever since, it's been just a blessing, because now you look at any knife, you pull out the knife from your pocket, you're like, oh, this is number 1020. And there's a date on the inside, June 2018 on this Norseman. It's so cool to be able to see that. So this Rask is Rask 101 from, get the light just right, March 2017. Near the end of production. That's cool. Actually, 2017, we made a lot of Rasks. We got from 100 to 320 or whatever. So we say Rask number 101. RWL 34 is the blade steel, and then on the current Rasks, I was like, well, we got a 5-axis machine. We can tilt the blade in all kinds of cool ways. So I was playing with different places to put it in, and I settled on the spine right here. And oh my goodness, did it ever turn out good. So it says Rask number 369, RWL 34, and it's clean, and I use a very small end mill, and it just looks so good. During the heat treat process, sometimes it gains a little bit of color. So what Sky does is he masks the blade a little bit after heat treat, and then he bead blasts that engraving just to clean it up, just to get any little color out of it and even it. And then just through tumbling and polishing and things like that, it kind of darkens up and the letters turn out super duper crisp, and it's amazing. All right, so we got a couple of Rasks here, but this one right here, our eye behind the lens there, Fraser, this is his knife. So something we do here at Grimsmo Knives is after after an employee's 3-month probation period, they get to dig through the scrap pile and put together a knife. And this guy right here was like, black, I want it all black. So he was able to pick out some black parts, silver pivot, and just the other day, him and Sky were kind of trading handles to make it blacker or better. And it turned out pretty nice. There's defects in the DLC. There's some problem areas. He also found a Damasteel clip that is, for whatever reason, not amazingly perfect, but oh, it's bent.
Look at it on the side, yeah.
Yeah,
it's jank.
That's funny.
Stepped on it.
Damasteel clips were really hard because we had to, they're not only hard to machine, but they have to be heat treated, and then they have to be polished, and then they have to be etched. And heat treating something so thin and weird shaped, and normally we quench parts between quenching plates to get the heat out quickly after the heat treat. It's really difficult to do that with Damasteel clip. But when we did the Rask pre-order, we're like, all right, pick whatever you want. Damascus, Damasteel, or colors, anodized, whatever. DLC was an option. And it worked, but we had a lot of work to do to make that list whole. It's funny looking at this older knife after working on the new ones for the past 6 months or more. The lock bar cutout is super visible on Fraser's knife here. The thickness of it, it looks huge. Whereas on the new one, it's like nice and beautiful, nice and tiny. I like it. So what I want to do right now is I want to take apart some of these knives. Start with the oldest one real quick. Probably right around, I forget when we started, but we switched everything to T9. We used to have a T8 pivot that we would buy from Alpha Knife Supply. This is the Torx screwdriver size. And then T10 screws that we would also buy. These are the T10 screws. And right around Norseman 500 and Rask everything, we started making our own screws. And they got better. So I always take apart the lock side. Knife comes apart. This has been carried a lot, so they're super dirty inside. Okay, let's take apart that one. And let's take apart one of the production knives. This was a gift to one of Barry's friends for hooking us up and helping us out sometimes. And there's some little issues with this one. It's kind of a friends and family model. But I thought it'd be perfect for the video. There's so many little tiny things I'm seeing on these older ones that I've gotten rid of on the new ones. Just tolerances or fits or whatever. You'll notice that these have 2 stop pins, which I don't know if anybody else is doing this. I know I certainly came up with it. It's amazing. It allows us to have 1 pin that controls the lockup and 1 pin that controls the detent, the closed flipping action. And you see how this one is stepped, goes down. We make them in 1 thou increments in 20 different sizes, so that when we're putting the knife together and we're fitting it up and Eric is doing the assembly, he can go, it's not quite, okay, I need a small pin, and lock bar needs to go over a little bit more, so I need a smaller big pin, and we can fine tune. It's amazing. They're really tricky to make though, because tolerances are critical. So these two look basically the same on the inside. And then we're going to take apart this brand new one before we sell it. I got to make super careful that I don't scratch anything. There is Loctite in there. Helps to put my thumb or my finger on the pivot so that it doesn't pop out and rotate. Kind of keep it lined up. So yeah, this knife is literally sellable. Fraser was like, should we film that and take it apart before we sell it? Yes, good idea, because the action on it is amazing. I love it. We use a torque wrench now to torque the screws down. I don't have one here, but I'll make sure to do it afterwards. Careful I don't mix up the stop pin sizes between all the different knives. Here we go. Okay. Look at this. Okay. That stop pin is tight. Okay. So we have changed the pattern, the milling pattern on the inside of the knife from this sort of diagonal one line to an X shape, because when we were making them on the Kern, we noticed that the handles were kind of bowing a little bit. So we thought we'd try an X shape to create more like, you know, the center is grabbing this corner and the center is grabbing that corner, and try to keep it from bowing, because this thing is milled on every single surface. It is, you know, face milled, it is pocketed. There's a lot of stresses and weird stuff that the end mills are doing to the material. You know, going in there, hogging it out, and then finishing it and putting 3D finish on every single surface. So they come out, I'm exaggerating here, but they come out like minor little tacos, maybe 0.010 of an inch up in the center. And then we bend them flat and we kind of get them all nice. But we were playing with the X shape to try to get, try to reduce that. Because if you look at the way this is shaped, you kind of think that it's pivoting, it's like bending at this line. And it kind of was. The X did help significantly. They're still bowing a little bit, so we're still bending everyone in the arbor press right now until we find a better method. But for now, that works super good. The spacers are identical, although we make them, we're like 2 lathes. From when I made these ones, we're 2 lathes later. Made these on my Tormac lathe, made these on the Nakamura lathe, and make these now on the Tornos Swiss lathe. We still have 2 of those lathes, and they're awesome. That's funny though. Lock bar stabilizer on both of these in pretty much the same position. Engraving is pretty much in the same position. Whereas over here, we're doing a lock bar insert. This is a hardened AEBL stainless steel, milled on the Kern, insane tolerances, heat treated, hardness checked. That's what these 2 little dimples are for right there. That's Sky going in with the Ames hardness tester and checking to make sure they're about 58 Rockwell. And then tumbled in the vibratory tumbler. There's a tiny little engraving on there. How close can you get there, Ryan? That little guy. Turned out good. So here, this is an insert. I literally made this today. It just came off the machine. It still has to be heat treated. It still has to be tumbled. I played with a bunch of different ways to make these lock bar inserts, and I'm going to do kind of a vlog style video on how and why and all that. So I'll try not to go too deep into it now, but they work great. And we've done a lot of testing. I've made dozens of inserts that didn't work, whether it be the hardness or the method or machining them hard or machining them soft, yada, yada, yada. I'll get deeper into that in the other video. But it looks so good now. Other than that, I mean, the lock bar cutout, the bendy section right here, is a little bit different between the first prototype and the production ones. Production and current production look about the same, although they look better on the Kern. And just surface finishes have gone up. On the first production ones, we did this crosshatch pattern on the inside of every single handle, no matter what was on the outside. But now, currently we're only making starburst pattern. It's on my list for this month to add more patterns. I want to match the pattern on the inside to the pattern on the outside because that's so extra. So when we do crosshatch, it's going to be crosshatch on the inside, crosshatch on the outside. That takes a bit more planning, a bit more logic in the fixtures to make sure they know what to do. But that's going to be sweet. Same bearings, also 2 lathes later. These were made Tormac and mill, and then on the Nakamura lathe, and then on the Swiss now. We still do make parts on the Nakamura lathe, but only pen parts, actually. Everything knife related happens on the Swiss. Yeah. So looking at all these, I'm trying to rack my brain, trying to remember like what I've changed. I don't keep a list of all this stuff. I just change on the fly, and if it works, it works. I keep it. Otherwise, I'll try it again. But I notice you can see on this blade, both these blades, actually, this one's different. This brings back memories. This detent hole in the blade, that's where this detent ball falls into to keep the knife closed. Click it closed, and then you have this perfect flipping action. This hole is huge, and I now remember we used to do that for all of our knives. It's good that the hole is bigger than the ball so that the ball only catches on this front edge. You don't want the ball touching anything on the back edge, but that's huge. And then as of 2015, I realized it doesn't have to be so big. It just needs to cup the front edge, and then the back is just a little bit of clearance. So that is basically how we do all of our knives now, except with the lock bar insert and the special way that I'm doing the lock bar insert, have to have this slot so that it clears not only the ball, but also this nub on the lock bar insert. And I'm going to explain that better on the lock insert vlog, but it has to be there and it looks cool. Other than that, they're very similar-ish in many different ways. I can actually see the surface finish here is just kind of the raw titanium, not awesome. And I can see some of the tool paths still here on this surface finish, even through the tumbling from when we milled it. And then now on the Kern, I still mill it like that. And we're not double disking or lapping the inside of these handles at all, as we do on the Norseman. We're milling it with an end mill like this. But the Kern being so awesome, and our tumblers being so awesome, and Eric and his finishing team being so awesome, you don't see any of those milling marks anymore. And then the engraving is a little bit different as well. Tiny little micro words, proudly made in Canada, Rask, February 2021. And although it is March, I haven't made my March dates yet. So that's on my list. So with the Kern, we've got up to 42,000 RPM. We've got 210 tools available. I can get in here with some tiny little end mills and do little features and floor finishes and beautiful discs. So that's one of the big reasons why the insert is how it is and lets me do what I want to do. They fit together quite nicely, very nicely actually. And the screws that we use here are similar to our regular handle screws, similar to these guys, except they're shorter and skinnier and less threads, and they're just smaller. So they're tricky to make. They're very tiny, but they're titanium. They can be anodized just like the regular screws, and then they go together and clamp that insert down. And then I kind of tap it to pop them out. The tolerances I'm holding on this part are pretty good. I'm trying to keep everything within a few 10,000ths of an inch in thickness and hole size. Because if they're not, then the knife goes together weird and you kind of feel it if it's wrong. So let's put together the new Rask and see how it feels. So I put in the small pin, put in the big pin. Like I said, I always like to assemble the display side first and then put the lock side on top of that. And quick little tip here. See how the lock bar is bent over? Just an ever so slight amount. That's what Eric tweaks. More will create a heavier lockup and a heavier detent. Less will make it a weak, floppy, gross knife. So we're trying to tune that fine-tune balance. Because right now, the nub, the bottom bump, is your over travel stop, preventing you from over traveling it and screwing up your spring tension. And due to the properties of the spring memory of titanium, you're never going to lose that set that you're at right now until you bend it like quite a bit over. Like on this is an old gross handle that is problems. But if I bend it, this far, it's starting to hold a set. But I have to move it pretty much this far for it to hold a set. And if I move it more, I can really start to ruin things. But it is movable. I've had people ask me, like, how do you bend titanium? It's a metal like everything else. It moves. And it holds a spring memory. Like some metals don't have a good memory. But titanium is cool like that. So let's put this thing back together. Make sure the pivot is pretty much up and down. I like to assemble it slightly closed. I just find that makes everything a little bit happier. Put my 2 screws in. Try not to scratch anything. I'll have to remember to torque these later before we sell it. Give it a good cleaning. This is the tool that we sell and include with every knife. So you guys are free to do this too. I'm not going to say we encourage our customers to take apart their knives, but we know they're going to do it anyway. And because of that, we want to make it easy and we want to make the knives go together like super good. Now, one of the magic sauces is how tight to make this pivot. It feels gummy because of the Loctite, so I'm kind of using my experience to tell. I go until I can feel it's stopping, gently. Oh, yep, it gets harder. That's kind of my perfect tension right there. And then I feel for blade play, nothing. And then I try to make the blade drop. Look at that. I like this one. And there's a lot of fine tuning that goes into making the blade drop, making the blade flip out perfectly. Because some of them feel soft, some of them feel like so hard, you're like, I can't get it out. And it's all fine tuning. So having the Kern, which is a super expensive, super fancy 5-axis milling machine center, allows us to control and to fine tune and to do everything I want to do, which is amazing. But yeah, goes together great because of the tolerances on the spacers and the screws and the pivot and everything. The knife really should just go together the same every time. You know, some knives, you literally have to be like, as you're tightening it down, bend the blade to the side and then tighten it down and then tighten this one and then that one and then the pivot. And there's like this order to make everything kind of line up and be happy. I don't want that. I want the knife so like, the hard work is on us to make it so precise and so consistent that the knife clicks together every time, easy peasy. You guys don't have to worry about it. They just go together. And it's great to hear from our customers that that theory actually works in the real world. The only thing you got to do every now and then is take it apart and clean it. Because these guys, especially this one, has probably been carried a lot. Because what we're trying to see is pocket lint ends up in this lock slot and kind of gets beat down on the two stop pins, open and closed. And I can actually flake this off. It's not so bad on this one, but can you see that? I'm actually pulling up some fluff. So a Q-tip works great for this. You just go in, clean it up, knife's brand new. If there's too much pocket lint, if you have a piece of sand in there, a piece of gross whatever, the knife might not open fully, or it might be spongy on the closed position, and quick cleaning, quick take apart, like makes it brand new. One of the things that I think our employee Sky and one of his customers / buddies were talking about adding little chamfers to the outside of the knife. And they kind of brought it up to me, and I was like, yeah, I'll see what I can do. So I added a micro chamfer all the way around on every, like normally we chamfer inside the stop pin slot, but I added a chamfer to the outside using a thread mill. That way I could do a top chamfer and a bottom chamfer with the same tool. I'm talking 1 or 2 thousandths of an inch chamfer, super duper tiny. And after it gets tumbled, you don't see it as a chamfer, but you just see it as a beautiful like blend as the light catches it and it shines and it just looks right. And it makes less deburring for Eric and his team to do too. So we'll get him in here in a minute and he can talk about what it's like to finish these knives. Because basically I make the parts and Eric and his guys make them pretty, finish them. So where I want to take the Rask and the Kern from now on is more production. I'm fine tuning all the little tolerances, all the tools, all the tool life. I'm tracking all that stuff. And as Eric will tell you, he's like, I just want more Rasks. Just give me more Rasks. They're so nice to put together. Right now I'm making one every night on our night cycle. And I only have the one tombstone. Once I make more tombstones, which I'm currently working on, then I'll be able to make more and more Rasks every day. And then, but I don't want to make more when there's still problems, because then you're just making life harder. You're compounding on the problems. I don't want to come back to several pallets worth of scrap in the morning because I haven't fixed that one thing yet. So I'm almost to the point where I can just crank her up and make more. So that's good. I do want to add more patterns. I'm really happy with the blade grinding. A couple little, like this one, I got to get rid of that because that's just not cool. I don't want to give this to Eric. I feel bad, actually. I usually write like little frowny faces or whatever before I hand it over. Like, sorry. I can fix that. I can do better. But yeah, for the most part, things are going really, really good. I'm super pumped to have now 2 knives on our inventory, you know, that we make, and they're different. They're different knives. You know, a lot of the same features, a lot of the same tolerances, same screws, similar pivots, but they're kind of, maybe I love my babies, but they're different, you know? The Norseman's big and chunky, and the Rask is like smaller and delicate, and I like it. Our customers like it. It's good. I don't want to make 50 different models of knives. I just want to make a few models really, really, really well. What's up, gangster?
I'm gonna be in that shop, so I could be like, and I don't have to do that anymore, and I don't have to do that, and
You probably cleaned it all up, made it nice. All right, so we're already rolling. We're just talking about Rasks. I talked for about a lot.
All right.
But I want to get your thoughts on, like I said, I machine the parts and I give them this way, and he creates this beautifulness. Talk about it. I mean, you've literally put together 5,000 knives that we've made,
Yes.
and now we're on to current knives. Just open up.
So yeah, I mean, with the new Rask, for one, it's way more consistent. Like the parts are, so far, they're more alike to each other than the Norsemen are, because we just have a bit of variation in the Norsemen codes and old fixtures and things that just have changed. Whereas the Rask is just kind of spot on every time, except for a few issues every once in a while.
Yeah, I showed him about the blade bevel thing.
Yeah.
You could talk about
But
it.
the good ones are all good.
Okay.
Yeah.
I like the sound of that.
But yeah, they're like the Rask Bevels, for the most part, aside from that one,
Yep.
are a lot better, a lot easier to finish up and make look good without having to spend, 45 minutes just grinding them.
So what was it like back in the day, back, 2015, 2017, grinding these bevels?
So yeah, they were kind of like, these ones, not quite that bad, but
They were streaky.
they were very streaky, and they had like highs and lows in the bevel.
Okay.
So if you tried to tumble it, you'd just see like
It made it worse.
way worse.
Like the tumbling doesn't
Yeah.
actually hide anything, does it?
No, like the Damasteel Rasks, like our number 1 and 2,
Yeah.
like they were not ground out, and they're just etched Damasteel, and they look great because you can hardly tell. But on a stone-washed one, it just no bueno.
Yeah.
Yeah.
It accentuates the scratches.
Yeah.
The lines.
Yeah, I mean overall the finish on the blade, like the spines and everything, are a lot better. And we actually have a sharpening choil in this one, so it's a lot easier to sharpen than the old ones. Yeah, and the best part is the lock bar insert. So one thing that I've always had to do with all the Norsemen and all the previous Rasks was carbonize the lock face so that the blade and the handles don't stick together, which is great in theory and usually works, but it doesn't work every time, and it's very easy to screw it up by chasing a problem. So if I carbonize a knife, put it together, and it has a little bit of lock stick, I play around with it. I buff one thing down, buff another thing down, and try to recarbonize and just go back and forth until it either doesn't stick anymore or I throw the knife out. So that's just not a good scenario to be in.
When you're talking about stick, you're talking about when the lock bar moves over, it gets stuck. And
Right.
there's like a pop, like a grit or... Yeah.
Right. So you never want to have to like force the lock bar to unlock.
Yeah, unless you go to Blade Show and you feel a lot of different knives
Yes.
out there. It's a very hard thing to do well.
And
even you, I mean, I was thinking the other day, I'm like, you're literally an expert at carbonizing. Like, that's your job.
And I still don't feel like it because it's not reliable.
An expert is just somebody who knows more than the next person.
I guess, yeah. But yeah, so the inconsistencies with that caused us to want to do the insert. And
Yeah, how's it working? Like, this was one of those things that was theory. It's like, I think it's going to work. I think, how hard do we make it? I don't know. What angle do we make everything at? I don't know. Let's try a bunch of stuff. And at first they didn't work.
Yeah, at first the lock just failed, and the geometry wasn't right, and but it just took a few tries to get it so they're rock solid lock up and no stick, hardly have to mess with anything. And I was gonna say finick, not but yeah, so it's just way more consistent and quick. I can finish a Norseman fairly quick, or it can be a double amount of time just because I'm chasing the lock face, whereas this will, like a Rask, is half the time.
That's fantastic.
Partly because the sharpening is half the job.
On the Norseman you got kind of two edges you treat separately, right?
Yep.
You sharpen the one first and then the other, or whatever order you do.
Yeah, and then you have to line all those edges up and get them all perfect, whereas this is one sweeping edge, which you still have to be careful with, but it's not nearly as time consuming. It's a lot thinner at the edge. I was just
gonna say, yeah. So how's that impact sharpening?
I can use an older, finer, worn-out belt, and it still works wonderfly and quickly. Whereas with the Norseman, I have to, use a bit rougher belts or do a few belts to be able to cut through the thickness of the edge down to a point and then clean it up.
Without screwing it up.
Right.
Yeah.
Yeah.
Yeah, when Eric's sharpening, we basically know, he's in the zone, leave him alone.
Yeah, if I jump, there's a problem.
It's literally like this, and if you need his attention, you'll come into his periphery. Don't touch him, don't whatever. It's he'll see you. Okay.
Yeah, it's getting better now. I'm less jumpy, over 5,000 knives. And more people in the shop. So
you're used to it.
Getting more used to it. But especially in the early days when we were just in the garage and it was the two of us, and I was just trying to sharpen the Norseman on the belt, and the air compressor would pop on and I'd just freak out. Oh, so bad.
PTSD. Jeez. That's funny.
But yeah.
Yeah, it was showing this Rask was made in the garage. This is the proto, the early one, right? And it's the only one we made in the garage, because then we got the Mori, and then we made Rask 1 and 2, yours and mine. And so the blade bevels, how did you used to do it on the back in the day?
So I used to do it. I had a disc grinder, and I had a 1/4-inch rubber pad on it with a radiused edge, and then I would just put sanding belts on it. And
for sandpaper, you'd a spray adhesive.
Spray adhesive, sandpaper. You have to cut the edges off the belt or the paper, and then just very carefully go in as it's spinning and try to grind the whole bevel down without screwing up the plunge too much and going too far that way or screwing up that edge. And it's just so many different things that I'd never done before, because before the Rask we'd never ground a bevel before.
Right.
So it was really time consuming, and went through a bunch of sandpaper and glue, and it was just messy and nasty and gross.
Yeah. And I remember it take you an hour per bevel.
Yeah. Yeah, depending on how good or bad they were, it would be 45 minutes to an hour at least.
Yeah. To do one, and we're trying to make more than one knife a day, and plus you got all kinds of other work to do. So
whereas now with the good ones, there's just a couple items that still have to kind of fix a little bit, but it's way more consistent. So I just fix the little area and then tumble it, and it's all good.
Yeah, one of the things he's talking about, so we have our die cut wheel. The blade is clamped to the tombstone with clamps, imagine my fingers were the clamps, and the grinding wheel has to get super close to those clamps. And as the wheel gets smaller, we just found out the other day, that when the wheel gets to a critical minimum diameter, it actually hits the clamp and creates a dip, a bump in the blade.
Yeah, it leaves 2 gouges right at the edge.
It looked consistent, and 2 or 3 blades in a row, and I'm like, what is that? And I'm looking at everything going, why is it doing that? I'm sorry, Eric, but can you fix it? And then we realized, the wheel is at our minimum. So, make the minimum a little bit bigger than that. Don't let it get that small. I actually made a custom cap. This is the aluminum cap that comes with it. I made a custom low profile one. And eventually I'm going to make my own holder completely from scratch that gives me better clearances, tolerances for my clamps, because it gets right up in there. And there's clamps in the way. So I'm trying to make it better. But the feedback is good. Like I encourage Eric and the other guys to like tell me what to fix so that I can make it better.
Yep. It's the only way it happens.
Yeah.
There have definitely been too many times where I just don't tell them what the problem is. I just fix it and move on and then deal with it again tomorrow and then fix it and move on. And
Yeah.
so we had one of those issues today that has just been a thing for years.
Yeah.
And it's like, can we change that now?
Is there anything else you want to see on the Rask, like going forward, or anything you want to apply from the Rask to the Norseman?
Well, there's a thing.
So after making 4,600 Norsemen,
Yeah.
and now we've got lock bar insert and some new things. What do you want?
Well, yeah, we're wanting the lock bar insert on the Norseman, obviously,
Yep.
because
I'm
that'll
this close.
save so much headache.
I'm like literally 90+% there.
Nice.
So that's good. Actually, I made them a few weeks ago, right? And you tested the first design. And what happened when you put it together? So I made a blade. They went through heat treat, through lapping, through bevel milling. Then I made the handles, and it's like a big thing. Then I made the insert fixture, and then I made the insert. And I'm like, okay, here, Eric, test this out.
Yeah, so I tested it out, and one thing we do is we spine whack the blade.
Every knife.
Every knife. So
Put
have
an
a-
overlay footage, like grab
have a
some
wood
later.
block, and then we just beat it like that to see if the lock will fail. And what happened with the Norseman, I don't know if we can see here.
Yeah, if you put it more in the middle.
Um,
And you can even go up to your elbows if you want to
you
get
see
closer.
that insert there. As I started to spine whack it, it started bending away from the handle towards, to stay with the blade, which is not good.
Yeah, and I realized it was one of those theories that it's like, if I put the two screws here, yeah, it'll be fine. It's rigid enough to do that, right?
Yeah,
Basically, the
which
two
were-
screws were in the back of the insert, leaving the front unsupported. So I thought it might be fine.
Yeah.
And then the insert just goes like this.
Yeah, so that didn't work, but now we know.
Back to the drawing board.
Yeah.
I redesigned it a couple weekends ago. I'm super happy with the new design. It looks better. It feels better. I did take that apart on video. And yeah, so the Norseman lock insert like 3.0 is going to be sweet. So
Yeah.
I'm hoping to give you test parts next week.
Okay.
I'm going to make the handles tonight and then blade and stuff next week. So
Nice.
yeah.
Yeah, that's probably the most exciting thing.
Yeah.
Can't really change the shape of the blade to make that easier.
Yeah, you're locked in now, man.
Yeah. What I want to see is just more Rasks. Like, we're still making more Norsemen than Rasks right now because he's figuring it out, and we're
Yeah.
only getting, maybe one Rask a day at the moment.
If it's good.
Yeah, if it's good.
Yeah.
But when I get those and finish those at the end of the day, that's like the best win after a day of Norsemen. It's like, yeah, I just want more.
Yep.
Yep.
Yeah, and meanwhile, I want to apply that to the Norseman to make Norseman better and smoother and more accurate and better tolerances and lock bar inserts and stuff. And then they're just like, no, Rasks, just all Rasks.
Mhm.
That's all I want right now.
We can come back to Norsemen.
Which is literally, that's what happened in 2017.
It is.
So you tell your side of that, like,
Yeah, so when we filled all the orders for the Rask,
right?
we learned a bunch of stuff making the Rasks, and we wanted to apply that to the Norseman. And since the Rask was kind of a pain with like the bevel and certain things, and you wanted to change the fixtures a bit, I think. So we decided to just move to the Norseman, make all the changes that we learned like with the Rask and all those improvements, put them onto the Norseman, made those fixtures, and then just started making Norsemen and kind of didn't get back to Rask for 3 years.
Yeah, almost 4.
Or 4.
And yeah.
Just because we wanted to get on a roll and get the Norseman back good again.
Yeah.
And now that was good for a while, and then it starts having issues again. Now we're like, Rask, please come back.
Flip-flopping.
Yeah.
But I think, honestly, from here on forward, I think we could probably do, I don't know if 50-50 is the right number, but, I want to do a lot of both.
Mhm.
I want to make, we've got 2 great products. I want to fine-tune, in this video we talked about a lot of the little things that we're still battling with, bevel grinding, tolerances, things like that. But everything we fine-tune, like there's a lot of things that have been implemented now that are not a problem anymore, that you used to have to deal with. Like, remember on every knife when we used to have to ream the handle holes as a pair, we'd put the 2 handles together and we'd pin them all and ream those two to make them line up. And luckily, as the machines get better and our capabilities get better, that's not a problem anymore.
Yep. Yeah, just all sorts of things, like, you know, not having to hand sand the flats of every blade, or yeah.
Before we did surface grinding or lapping, I remember you used to have these 2 big magnets with duct tape all over them, and you'd slap the blade to the magnets and hold it up against that disc sander to do the flats of the blade.
Yeah.
You don't have to do that anymore. You have a Steven for that now.
A Steven and a lapping machine.
Yeah. And that's how the blades come out, you know, super shine like this. And this finish tumbles out like.
Yep. Yeah, we don't have to touch that finish at all.
Yeah. So now that we're selling the new Rasks, this is $369 going up today. We started at $330 was the first one, right?
Yeah, I think so.
So we've made 40 Rasks here on the current, which is good. And if you want one, link in the description to our website. The demand is like we had 4 years of pent up demand as people like, where's a Rask? I want a Rask. I want a Rask.
They were thirsty.
Yeah. So there's a lot of people that want Rasks, which is great, but they got to be perfect. I'm not just going to put garbage out there. But yeah, the way we're doing it right now is the sign up form will add you to our Maker's Choice list. And then currently we're making it however we want. You guys pick the colors and blade finishes and everything, and I pick the machining patterns. We put it up on the website. We randomly pick names from that list, and then if you get picked, you have the choice to buy it or not. And that system's working great. On the Norseman, we also have the buyer's choice system. Same list. We randomly pick names, say, hey, do you want to buy one? Here's the order list, and you get to choose your color, your pattern, your screw color, your blade finish, et cetera, et cetera, et cetera. And that works really good. We're currently redesigning that whole back-end system. Want to apply that to Rasks and Sagas and Norsemen, and that's good. So yeah. Anything else?
No. Sign up for the list. Like, subscribe.
Thanks for watching,
that
guys.
stuff.
Hope you like the nerdy deep dive, and sounds good. All right. See ya. Bye.